I'm Norman Wahlberger. Today I'm going to give an introduction to Geometer Sketchpad, which is a very powerful and beautiful software package that allows us to visualize geometrical constructions and to manipulate them to discover things and to enhance our understanding of geometry. Geometer Sketchpad is one of a number of different programs, and later on I'm going to tell you about some of the other programs that accomplish similar things. These are very important tools, and they're helping push geometry back into the center of mathematics, back into the center of curriculum for mathematics in many places. So Geometer Sketchpad, and we're going to apply it to understanding circles today in hyperbolic geometry. Geometer Sketchpad was created by Nicolas Jaquet. I hope I'm pronouncing that right. It's used extensively in schools and colleges, particularly in America. It allows the user to create custom tools. So in this video we're going to give a brief introduction to GSP, tell you a little bit about custom tools, and then show you how it illustrates circles in universal hyperbolic geometry. So this complements the last lecture where I drew pictures, sort of freehand, of these things. Now you're going to be able to see more accurate pictures of circles, and you're going to be able to see more accurate quadrances associated to circles. And we're going to look at the three different examples that we had a look at last time using Geometer's Sketchpad.
Geometer's Sketchpad is a lovely program for creating dynamic geometry visualization. We're able to construct interesting geometrical objects, manipulate them, and all the while see what's happening. So this lecture now is going to introduce this program. We're going to go over some basic constructions in GSP. We're going to have a look at custom tools and how to create them, and then I'm going to show you how to use some special custom tools to visualize circles in universal hyperbolic geometry. So let's start with the basic setup here, the Geometer Sketchpad worksheet. On the left hand side we can see a whole bunch of tools that are used for making constructions and some other things. So let's have a look at these various tools. The first one here is the kind of select button that allows you to select various things. This button is a tool that makes points. So we can create some points. Perhaps we would like our point to be a different color. Let's make it orange. So there are 3 points that we've constructed using this point tool. Now let's make some lines using this tool right here. So we'll click on that, and then with our left button we'll click this one, and then this one, and then this one, and this one, and then again this one and this one. We get the 3 lines joining the 3 points. We'll go back up here to get out of the line mode, and to make the points a little bit bigger, let's select all of them, and under display we will change their colors. Now we'll change their size to large. Now observe that when we drag these points just by holding down the left mouse button and dragging, then the lines move correspondingly, and this is one of the main features of Geometer Sketchpad. Now let's have a look at some other constructions that we can do. We can make some circles. We can make a circle centered at any point with any radius. We could, if we wanted to, also create a circle with the center a given existing point, for example this one here, and we could move it until it meets another point where it sort of clicks to it, and then we would get a circle like that. In terms of the lines, these little arrows here give us more than one possibility. So if we're interested in a line segment between 2 points, we could do that one. If we want a ray between 2 points, we can do something like this. Well, if we want a line, well then if we want a line, then we just get a 2-sided line like that. This tool here creates a polygon for us. If we create a bunch of points, there's a triangle, there is a quadrilateral, there's a pentagon. Once we go back to the starting point, then we've created a polygon, in this case a pentagon. And we can still move the vertices around. The A represents text. If we want to make a little note, we can say this is some text, and that can be part of the diagram explaining something for our own benefit, recording something or labeling something. The pen allows us to draw freehand. We won't be doing too much of that. The eye is a little bit of an information tool that allows us to click on something and find out some piece of information about it. The most interesting button is this custom tool button here, which creates tools and allows us to use tools that we've already got. You see that this document already has a tool that's created, the Ortho Center tool, so let's click on that and see what it does. So we're going to look at this triangle right here. I'm going to click on the 3 vertices in their order, 1, 2, 3, and we see a new point created. This is the ortho center of this triangle. To let you see the triangle a little bit more clearly, I'll select those 3 points and then press Control P on my keyboard. That will give us the polygon form of the 3 points. So the green point here is the ortho center of this triangle. So let's have a look to see how we got that custom tool. To do that, I'm going to clear the page a little bit of all the stuff that we've been doing. So the easiest way to do that is to use Control Z. Control Z undoes various constructions, so repeated Control Zs will eliminate the things that we've already done, leaving us with just this starting circle. And maybe we'll keep the interior, so Control P to make interior, and yellow is a little bit easier to see. Okay, so now I'm going to show you some of the things that we can access here through this menu bar here. In particular, the construct operation, which allows us to construct various things depending on what we've selected. Currently, we haven't selected anything, so we can't construct anything. But let's try to construct the ortho center of this triangle. To do that, we'll select one of the sides and the opposite vertex, and under construct now we see that there are 2 things that we could do. We could create a parallel line or a perpendicular line. The parallel line would create a line through this point parallel to the given line, so in this direction. But we'll press perpendicular line, getting a line that's perpendicular to our chosen line. And we'll give it a different color so we can see it a little bit better, say blue. That's just an altitude of this triangle. Of course, we can do that for the other side, so we could choose this side and that point opposite and construct the perpendicular line to get another altitude, or we could choose this point and this side, construct perpendicular line. There are the 3 altitudes. And hopefully you're not surprised to see them meeting in the ortho center. Let's click the ortho center, give it a little bit of a different color. There we go. So if you hadn't seen this before, you should possibly be amazed at the concurrence of these 3 lines. And now we can create a custom tool that allows us to forego having to make this construction every time we want the ortho center of a triangle. So what we do to make this custom tool is, first of all, we start with the initial objects, which were the 3 points, and then the final object. We can disregard all the intermediate constructions because the program knows what they are. Then we'll come over here to this button, we'll click it, holding it down we'll see the option of Create New Tool, and we'll take that option. We'll give this tool a name, Ortho Center, and we'll show a script view. A custom tool with that name already exists. Do you want to replace it? Well, yes. What is this? This is a description of the actual steps that we've employed, or that the computer employs, in order to follow our construction of that ortho center. So now to apply this tool, suppose we just click on it. It's already clicked, but let's click it again. Now we choose any 3 points, and we are getting the 4th point constructed automatically, which is the orthocenter of the 3 points that we've started with. So this way we can create orthocenters at will, because we've done it once and we've recorded the construction using our custom tool. Now let's have a look at some custom tools for hyperbolic geometry. So for that, I'm going to close this particular document. We'll open this document, which is my basic document for doing hyperbolic geometry. And what you'll see is a circle. You won't be surprised to learn that this is the null circle that we're using all the time in hyperbolic geometry. And there are 2 little points here. I might make them a little bit bigger. Select them, point size, say medium. They allow us to move the circle around and to expand or contract the size of the circle if we want to. So we'll leave it like that for now, and we'll hide those points because we don't really need them for the hyperbolic geometry. Now, one of the main operations that we want to do is to find the polar of a point, or the dual of a point. And here now you see this particular document has not just one custom tool, but there's a whole bunch of custom tools that I've created, and they're all having to do with hyperbolic geometry. They all allow us to do interesting things in universal hyperbolic geometry. So the first one is the polar one. Let's have a look at that. That creates the dual line for a point. And I might make that a little bit thicker so you can see it a little bit better. Line style medium. Okay, so this point here has a dual line, this one here, and conversely this line has a dual point here. And it behaves like the dual should. Let me show you how I constructed that tool. So suppose we get rid of this one, we'll delete them both, and I'll need the original points. I'm now going to show you how to construct the dual of a point, which is a very important construction. We've already gone through it in the series, but I'll show it to you here in Geometry Sketchpad. So first we need a point, that one there, and let's make it large. And now what I'm going to do is I want to have 2 lines that go through this point and meet the circle. Well, that can be done in various ways. I'm going to do it in a way that's kind of consistent. So I'm going to first create a line between this point and the center of the circle. The line doesn't have to be pink. Let's make it something a little bit less bold, say just black. And then from this line through the center, I'm going to construct a perpendicular line with the sole purpose of getting these 2 points here, and let's make them say gray. Now what am I going to do with these 2 points? I'm just going to use them to create lines from our starting point that pass through the circle in 2 points each. So I have not just these 2 points, but I also now have these 2 points of intersection between the circle and the 2 lines emanating from here. Now at this point, this line and this line are really no longer needed. We could hide them by doing a Control H. That just hides that point. In fact, we don't need the center of the circle anymore either, so we just need this point and the 4 points that we've constructed now. So how am I going to find the dual? I'm going to create a few more lines. I'm going to join these 2, and I'm going to join these 2, and I'm going to join these 2. So now these 4 gray points, forming a quadrangle, have been joined by all 6 lines. And there are 3 diagonal points. The one we started with is 1. There's another diagonal point. Let's color it something else, say red. And then there's another diagonal point, which is the meet of these 2 lines. Where do these two lines meet? Well, they're parallel, and so they're not going to actually meet in the finite plane, but they meet at infinity in that direction. So the line through this one and that other diagonal point is just perpendicular to the line through here. So maybe we need that line again. Let's put it in again, and now selecting that line and this point, we are going to construct a perpendicular line. Or I could also have just selected this point and one of these lines and made a parallel line. Would have done the same thing. And this point here that we've now constructed is the line that we're after. Let's color it a blue. That is the dual of this point that we started with. And you can see that it behaves the way it should. Alright, so what we have here is that construction being coded as a custom tool, so we can use it whenever we want with respect to this fixed null circle that's kind of always in our diagram. Alright, so let's get rid of some of these things and go back to our null circle, and I want to show you some circles now in hyperbolic geometry. We've been studying circles in our last video, and now I want to give you some accurate pictures of them as constructed by this particular custom tool, the circle through center and point. Alright, so there's a center and there's a point, and there is the circle through this point with this as its center. Let me make this perhaps black. Let's make the circle, first of all, thicker and perhaps a different color. How about light blue? And maybe that's not too easy to see. Maybe we'll use red. And this point here, which is variable, I like to color variable points green. Alright, so here we have, maybe we can give this point a name so we can see it. If I right click on anything, I get this properties kind of box, and I can label this point. Let's call it C for center, and I'm going to show this label. There it is there, and I'm going to make it a little bit bigger. Maybe not that big. There it is there. So here is another point. Let's call this X. I'm going to show that as well. There it is there. So here we have the circle with center C and through the point X. Let's make a box that says that. The circle with center C through X. I'm going to make that all bigger by highlighting it. And going down here to the bottom, there's an extra box that has a text size. There we go. Alright, there's one more thing we'd like to know, is what is the quadrants between X and C? So, well, there is another tool here, very conveniently, that tells us what the quadrants is. And if I click that one and then that one, I get this little box coming up, which is not very big, so let's make it a little bit bigger. And perhaps we'll move it down here. And to get a few more decimal places, we'll right click it, and under value we will increase the value to 10 thousandths. So that's the quadrants between our center of the circle and this point. So that's the quadrants that we were calling K of the circle. So let's move the point first to the center. This is our first example of circles, and here you can see circles of small negative quadrants, the negative quadrants becoming more and more negative, minus 0.5, minus 1, minus 2, minus 6, minus 43, minus 135, approaching infinity as x approaches the null circle. And then as it crosses, it's actually undefined on the null circle, but as it crosses, we get a big positive value. Something like that, which then decreases 5, 4, 3, 2, 1, 1.3, 1.2, 1.1, 1.0, and as we keep on going, the quadrants approaches slowly 1, and only change the value 1 once x gets to the line at infinity. So our second example was when we had our circle more somewhere like that, centered, and here then again are the various quadrants. Thing to watch there. Okay, the quadrants is becoming more and more negative. These are all the various circles. They're all ellipses on our page. And the ellipses getting more and more bigger, but eventually becoming hyperbolas. And these hyperbolas approach a certain line, and that line is the dual of the point C. There it is there. This shows all the circles centered at C. These ones with positive quadrants, starting from 1, increasing slowly, 1, 1.5, 2, 3, 4, and then up to infinity rather rapidly. And then from minus infinity down to, or up to, 0 eventually. And our third example, we had C being outside the null circle. Its dual line then meets the null circle at 2 points. These are important points. Let's show them. Give them some different color, perhaps gray. Not this one, we'll keep that one blue. Okay, so that's the center C. As the point X moves, what happens? The circles are all ellipses, as you can see. They're all tangent to the null circle at these 2 points. There's a 1-parameter family of such ellipses. That's 4 conditions. They go through these 2 points and are tangent to the null circle at these 2 points. So there's a 1-parameter family, and here you're seeing all of them. Ellipses like this, with various quadrants starting from 1 going up to positive infinity, and then minus infinity, minus 2 up to minus 1, minus 0.2, eventually becoming hyperbolas as the quadrants approaches 0. And once the quadrants is exactly 0, then we're getting the 2 tangents. Let's draw them. There's one there, and there's one there. I might color them green, say. So those are the tangent lines. They're the points where the quadrants is 0. So if we are on one of those tangent lines, then the quadrants is pretty well 0. And as we go across those lines, well, then the quadrants becomes slightly positive and increases more and more positive, getting closer and closer to 1. 1 in the limiting case when the hyperbolas almost sandwich the outside of the dual line. So there's a nice spectrum. Those are all the conics that go through these 2 points and are tangent to the null circle at those 2 points. That's the family of all curves, all the circles, centered C in this hyperbolic plane. Alright, so that's been our introduction to Geometer's Sketchpad.
So we can see that Geometer's Sketchpad is a very powerful tool. And next time we're going to carry on exploring metrical notions with Geometer's Sketchpad. We're going to see how quadrants and spread play out, and we're going to actually play around with the various trigonometric laws that I've said we're going to concentrate on, and we're going to see how they work in practice. So I hope you'll join me for that. I'm Norman Wildberger. Thanks for listening.